Hello everyone. This video is to help you set up your applications of solving equations. So you will still need to solve these equations on your own, but this is to help you with your setup. So on the front page, it's just translating. So it's just literally taking the word, the English word, and translating it to the corresponding mathematical symbol. So if you need some help with those, there should be an attached notes page on your Google Classroom that has some keywords and phrases and what operation it means, as well as some examples and the translation. Okay, so what you can do when you are just translating, remember that these are equations, so that means that every single one of these are going to have an equal sign. Okay, what you're going to do is you're just going to go through and you're going to look for those keywords or phrases that represent a mathematical symbol. So right here it says the total. So the total, I need to figure out what the word total means. Okay, and so when I go through and I look at my keywords and phrases, I see the total. Right here it means addition. So the total, I'm going to be adding some quantities. Now, I'm not just going to start off with a plus. We don't have an equation that starts off with a plus sign. This is saying I'm going to add two quantities. And so what I'm looking for is the word and, the linking word that's going to link the two quantities together. And where I see that word and is where the addition symbol is going to go. Okay, so the total of 4 and a number x. So what I need to do is I need to take 4 and the number x, and I need to total them. I need to add them together. So 4 and the number x are being totaled. Is big, it's a keyword, it's an important keyword for equals. Okay, remember all of these are equations, so all of them are going to have an equal sign. So you're going to see the word is, you might see the word equals, is the same as, yields, amounts to, all of those means equals. Okay, so equals 10. Right? And that's what you're going to do on the first page of this applications of solving equations worksheet, is just go through and translate. And then once you've translated, then you need to solve your equation. Actually find what does the value of the variable what is it in that equation. So I'd go through and I would separate the left-hand side and the right-hand side of my equation. I find my variable, and then I look to see what operation am I doing to that variable and how can I undo it to get my variable by itself. So that I'm going to leave for you to do on your own. The purpose of this video is to help with the setup in case you are stuck with any of these problems. Okay, so on question number 2, it says twice a number x is 20. So there's that is word again. So is 20. So this is going to equal 20. So now I need to figure out, what does twice a number mean? So twice a number, if you don't know, again, you can just go back to the notes page that's attached on Google Classroom. And twice is another way of saying double, which means I'm just going to take whatever that value is and double it. I'm going to take twice. I'm going to take 2 times that amount. Now, when I write this, I don't use a sign for addition. I had to put the plus sign. But when I'm doing multiplication, I don't actually put in a sign. So when I do twice a number x, I'm just going to do 2x. Okay, don't get confused and put that x for multiplication. Don't do that. Okay, if you just attach your two values that you're going to be multiplying, okay, the no symbol means implied multiplication. So 2x equals 20, there's your equation, and then now you'd go through and you would solve to find the actual value of x. Okay, question number 3, it says the difference of a number x and 5 is 7. Okay, so as I'm going through and reading this, the first word I see after the is difference. So I come back here and I'm looking for the word difference. Right here I see the difference of, that means subtraction. Now with subtraction, you need to pay attention to your order. So it's taking the difference of a number x and 5. Okay, so just like with the addition, I don't start off with the minus sign. I'm looking for the linking verb, and it's telling me that linking word and is telling me what 2 values I'm going to be subtracting. Okay, now pay attention to which one is listed first. X is listed first, so I'm going to write down x first. and is telling me where the subtraction is going to go. And then I'm subtracting 5, the difference of x and 5. So x minus 5 is 7. Okay, again, the reason why I went in this order, okay, the minus sign goes where that word and is, and since x was listed first, I need to put x first in my equation. Versus number 4, this is a tricky one. 2 less than a number equals 1. So I know the equals 1 part. Okay, it's this side. 2 less than a number. 2 less than a number. So 2 is how much it's less than this other value. So that means that this other value is actually the larger quantity. If you don't know that less than means subtraction, you can go to the notes page and see that less than means subtraction. But it's backwards construction. Okay, you'd be tempted because you see the 2 first to write 2 minus x, but that's not how this works. X is the larger value and we're taking 2 less than that amount. Okay, so we need to switch the order around. With subtraction, the order that you subtract matters. So we're going to have to put x and then put minus 2 and then equals the 1 and then go from there. Question number 5, it says negative 5 times the number x is the same as 15. So I'm going to start off with right here. It says negative 5, so negative 5 times a number x. So don't do that times x. Don't do that. Don't use the symbol for multiplication. Remember, all you need to do is attach the number to the variable and its implied multiplication. So negative 5 times the number x is the same as, so equals, is the same as equals 15. Okay, the last one, it says the sum of 8 and 3 times the number x equals the sum of 5 times the number x and 10. So quite a bit, but I'm just going to take it down, break it down word by word. So the sum. Sum, I look on here for where it says sum, and sum means addition. It works a lot like that word total, and I'm not starting off with the plus sign. Instead, I'm looking for that linking word and to show where the plus sign is going to go. What am I going to be adding? What values? So the sum of 8, I'm starting off with 8, and, so there's where the plus goes, 3 times the number x. So 3 times the number x, remember multiplication, I'm just going to do 3x, attach them, and that's implied multiplication. Do not use a sign. So 3 times the number x equals the sum, so that's also a plus, but that's not where it goes. It doesn't go until we see that word and. So what we're going to write next is this part, 5 times the number x. So 5 times the number x, which is just 5x, and, which means we now use the addition sign, 10. So there's your setup for numbers 1 through 6. You're not finished with this worksheet, just setting up. Now make sure that you go back through and that you solve, and that you make sure that your answers are correct. The last part of this worksheet, the second page, is about writing equations, setting up equations. So it's not just translating. Okay, now we're going to read a scenario and we're going to try to answer the question that's being asked. So notice that on every single one of these, I have the same setup. I ask you to define the variable, write your equation, and then what's the solution? What's the answer to the question? So first thing you're going to do is read each scenario. So this one says the first stage of a rocket burns 28 seconds longer than the second stage. If the total burning time for both stages is 152 seconds, how long does each stage burn? Okay, well, actually, we don't know two things, but we know that they are related. Okay, but we don't know how long either stage burns. So what we can do is we can use a variable. I'm going to use x to represent one of these stages. All right, so I'm going to say that X represents the length of the first stage. So first stage length. Okay, I also don't know what my second stage is, the length of the second stage is, but I know that it's related to the first stage and that the first stage burns 28 seconds longer than the second stage. So my first stage, which is X, the first stage, I just said that's X, that's my variable I don't know. It burns 28 seconds longer than the second stage. So 28 seconds longer, that means if I take X minus 28, that's going to give me the second stage length. So my first stage is X, and then whatever that first stage length is, minus 28, that's going to give me the length of the second stage. Now, that's not an equation. Those are my unknown values. I don't know what the length of the first stage is, nor do I know the length of the second stage. So now what I'm going to do is go back through and try to figure out a relationship. Try to set up an equation, which means I'm going to have an equal sign. So I already used this first sentence to come up with my variables. Well, one variable really. And then it says if the total, so total, remember that is addition. If the total burning time for both stages is, that means the equals 152 seconds, how long does each stage burn? So what I'm going to be doing is I'm going to be adding the two stages together, the first stage plus the second stage, both of those lengths. So I'm going to take X plus X minus 28, and then that is, so equals 152. So now it's up to you to go through and solve this equation. X represents the length of the first stage, and then if you take whatever X is and subtract 28, then you'll have your length of the second stage of how long this rocket burns. The next example is a pretty typical example when it comes to solving equations. Money, working with money, something that we all will do in our lifetime. Whether you do it right now or if this is to come later, it's always a good idea to start saving money. So suppose you want to start saving money. You open a savings account and initially deposit $150 into the account. If you continue to deposit $50 a week without making any withdrawals, how many weeks will it take you to reach a balance of $1,000? Okay, so I know you, or I know some of you are already starting to try to figure this out in your head. And that's good. Okay, sometimes our brains can figure these story problems out just by doing some kind of guess and check in our brains. Okay, now here I'm going to show you a way where you don't have to do guess and check. I'm going to show you how you can define your variable, set up your equation that's going to work through and solve this to figure out how many weeks it's going to take to reach that balance of $1,000. Okay, so that's what we're trying to figure out. How many weeks will it take to reach a balance of $1,000? So I'm going to define my variable. I'm going to use the typical X, and that's going to represent the number of weeks it will take to reach a balance of $1,000. Now, I'm not going to write all of that out, but I am going to put the important part that it represents a quantity. What number does it represent? It's representing the number of weeks. Okay, so now I need an equation. So suppose you want to start saving money. That's background information, but that's not really telling me any relationship between numbers. So I move on. You open a savings account and initially deposit $150 in the account. Okay, so that's your starting. So I'm going to go ahead and start with that number. $150 goes into that account. If you continue to deposit $50 a week, okay, so I don't know how familiar you are with banking accounts, but if you deposit money, you are adding money, versus if you are taking out money, that means that you are going to be subtracting money. But we are putting money into the savings account. We're depositing, which means that we are adding $50 a week. So $50 for the first week, $100 for the second week, and we need to represent any amount of weeks, and so we have x that represents that variable. So 50 times x. We are trying to make this the balance in the savings account be $1,000, so it needs to be equal to $1,000. So the left side of this represents how much money we're putting into the bank, and the right-hand side of the equation represents how much money we want in the bank. And so when these two values are equal, whatever x is telling us, well, that's the number of weeks it takes to make that balance be 1,000 in the bank. All right, so now you'd go through and you'd solve this, and x represents that number of weeks. Question number 9 says a person receives a salary of $600 a month and a commission 10% on all sales made. If in 1 month this person makes a total of $2,400, how much was made in sales for that month? So reading through this, here's my question. How much was made in sales for that month? That's what we don't know. So I'm going to let X represent how much was made. So the money made in sales for that month. Okay, so now going back through, it says a person receives a salary. So that means that they get $600 no matter what. That's what it means to be on salary. That you get so much money for so much time that you put in, no matter what. And a 10% commission. So if this is representing how much money they make, they get $600 no matter what, plus 10% commission on all sales made. Now, 10%, we don't want to work with percents. Percents they're decimals that have been multiplied by 100. So what we need to do is we need to divide by 100, which means that when you convert a percent to a decimal, so 10% is 10.0%, what you're going to do is you're going to take that decimal place and move it 2 places to the left. Okay, so here our decimal gets moved. So this is going to be 0.10. Notice the 1 is in the tenths place. 10%, it's now in the tenths place. Okay, so this is 10% of all sales made. We don't know how much sales were made, and that's why we have our variable x that represents how much sales were made. So 0.10 times x. In 1 month, this person makes a total. Remember, that means addition. We've already added these two values that represents how they make money. They make a total of, so this equals $2,400. So there's your equation. Go through, work backwards, find x, and that will represent how much money was made in sales for that month when the person made a total of $2,400. Right, the last question's kind of tricky. It says a city park is opening a new swimming pool. You can pay a daily entrance fee of $3 or purchase a membership for the 12-week summer season for $30 and pay $1 per day to swim. How many days would you have to swim to make the membership worthwhile? All right, so what we don't know, how many days would you have to swim to make the membership worthwhile? So we're going to let x represent the number of days. That's what we're trying to figure out, is your number of days. All right, so this isn't going to just be equal to some amount. What we're trying to do is we're trying to figure out when the two values are going to be equal. Okay, so what we're trying to figure out is when the daily admission is going to be equal to the membership. Okay, when those two values are equal, okay, obviously it wouldn't matter if you've purchased the membership versus paying daily. Okay, but before that amount, okay, your daily is going to be cheaper. And then after this amount, then your membership's going to be cheaper. All right, but if you're only going to go for 1 day, hopefully you can see that paying $3 would be a lot better than paying $31. All right, and what I did there to figure that out is your daily is $3 per day. Okay, so if you only go 1 day, it's $3. If you go 2 days, it's $6. If you go 5 days, it's $15. It's $3 per day, which means it's $3 times x, which represents the number of days. So 3x represents how much you pay for the daily rate. okay, with X representing how many days you go. Now we need to write a relationship for the membership, how much you pay for the membership. It's a $30 fee, which sounds like a lot, but it lowers the $3 rate to $1 rate. Okay, so you still have to pay $30 plus a daily rate, but now it's only $1 per how many days you go. Okay, so 3x equals 30 plus 1x. This is going to be the equation that you solve, and this is going to tell you when the values are equal. Okay, so that's going to tell you when. It doesn't matter how many, or if you pay daily or if you pay for the membership, because these values are going to be the same. But the question asks, how many days would you have to swim to make the membership worthwhile? Okay, so what you're going to need to do is you're going to need to figure out what x is, but then you're going to have to take it one day past, which is going to be when the membership is actually going to be the cheaper option. Okay, because if you just figure out what x is, that's when it's going to be the same value, the same amount for the daily and the membership. But if you go one past x, so if you take whatever x plus 1 is, that's going to really answer this question. I hope this video helps. Again, this is not the completion of this worksheet. All I've done is help you set up your application problems, and then now it's up to you to continue on and solve them and check them. Right, good luck, and of course, always email me or ask me questions if you have any more questions.